Hello, Psychology of Learning students. So the purpose of this short video is to go through Chapter 11, Generalization, Discrimination, and Stimulus Control. So in this video, I'm going to talk about Chapter 11. This week, we're going to cover Chapter 12 also. So in the next video, I'll talk about Chapter 12. In fact, I think for Chapter 12, there's going to be 2 videos. But Chapter 11, I think we can get it done in 1 video. So let me share my screen so you can look at the PowerPoint slides along with me. And by now, you know where to find these. So I'm going to talk about generalization, then discrimination, then stimulus control. And your book talks about, does a behavior analysis, talking about mental rotation, concept formation, and smoking relapse to sort of bring these examples home. So what is generalization? Well, it's the tendency for an effect of learning to spread or transfer. And if you think about it, if generalization didn't occur, probably the species wouldn't have survived. Every single thing that you'd have to learn would be, you'd have to have the exact same stimulus and everything, the same situation, everything would have to be the same. And so it would take so much longer for us to learn things. So I'm just going to use a quick operant conditioning example. I think when we were talking about operant conditioning, I talked about how if I had a really bad headache, so that's a situation, and I took an aspirin or an Advil, I think. I took an Advil, and then the consequence was my headache went away. So next time I have a headache, I'm going to be more likely to take Advil. So, and that we talked about how that's negative reinforcement because something is taken away from the organism, the headache, that increases the likelihood of them acting that way again, doing that behavior again, taking the Advil when they have a headache in that situation. So that's sort of like just a review real quick. Imagine if, okay, now let's say my knee hurts. Because of generalization, I might try to take an Advil for my knee hurting. Imagine if every single kind of pain that you had, you had to learn from scratch, how less efficient that would be than, boy, when I had a headache, Advil worked. When my knee hurts, let me try Advil again and see what happens. So the generalization really helps us as a species to more efficiently learn things, to be almost good at trial and error, trying things that are similar to things that happened before. So there's different kinds of generalization. We can generalize across people, vicarious generalization, across time, response maintenance, which is sort of the opposite of forgetting, across behavior, response generalization, and across situations, stimulus generalization. Now, most of the time, like if you take a class in general psychology, when we're talking about learning, when we talk about learning like when we're not teaching psych of learning and we're talking about more generally, when you hear the term generalization, most of the time people are talking about stimulus generalization. But really there are 4 different types. Let's talk about each one in turn. So the first one, generalization across people, is actually observational learning. It's what all of Chapter 10 was about that you learned about last week. And of course, Dr. Stephanie Stern created these slides, and this picture here is an ode to the Bobo doll experiment, you can see. So learning moves from the model to the observer. We watch a model get reinforced for doing a behavior, then we're more likely to do that behavior. We don't actually have to do trial and error and look at the Bobo doll and see how we want to respond. We're going to go, boy, I watched a model sit on the Bobo doll and get cheered for doing so. So now I'm going to sit on the Bobo doll. Okay. Generalization across time, we're going to actually talk about in the next video, Chapter 12, with forgetting. We're actually talking about the opposite of it. So if you don't generalize across time, then you get forgetting. So we'll talk about forgetting in the next video. Generalization across behaviors, that's response generalization. So this is when a change in one behavior that you learn by it being reinforced or punished spreads to other behaviors. So let's do a reinforcement example. If we're reinforced for saying hello to other people, we might start asking people how they're doing too. So hello, you go, oh, good, look at you for being friendly. And the next person comes along, hello, how are you doing today? So you can see our response generalizes not just from saying hello, but for actually starting to engage in in a conversation. The picture that Dr. Stern has here is if a child is rewarded for being willing to share a particular toy, then the child may generalize to the response of sharing a different toy, and may even share to doing may even generalize to sharing to a different child. So you reinforce your child, you cheer them, look at you, what a great sharer you are for sharing one toy, and then you notice that they're sharing a different toy with even a different kid. And so you can see how that response generalized to different toys, different share partners. And so that's response generalization. And then stimulus generalization, which is what we usually when people say generalization, this is what they're talking about. So the change in behavior during one situation spreads to another situation. Now, in order for us to call it stimulus generalization, then the stimulus that it's generalized to cannot have been present during training or conditioning. If it was present during training or conditioning, then it's not generalization, it's just regular learning. Okay, so let's do a famous classical conditioning example. This is Little Albert. This picture really isn't Little Albert, but let's use the example Little Albert. So remember, we're going back to classical conditioning. You even watched a video of Little Albert where Watson took this little boy who was in an orphanage, and I don't think it was actually an orphanage, but something like that. And he would show the baby the white rat. So that's your conditioned stimulus. Then a loud noise would happen behind Little Albert's head. And so that noise would startle and make Little Albert afraid. So white rat, loud noise, fear. White rat, loud noise, fear. White rat, loud noise, fear. Eventually, Little Albert sees that white rat and he's afraid. So that conditioned stimulus led to the conditioned response of fear. Okay. But what they found, so he was conditioned through classical conditioning to fear white rats. But what they found, Watson and his, was that not only was Little Albert afraid of white rats, but he had generalized this fear to stimuli that were similar to that CS, that were similar to white rats. So he was afraid of Santa. In other words, if you put a white beard on someone, he'd be afraid. That white beard was similar enough to the white rat that Little Albert generalized the fear from the white rats to also white beards like Santa, to white bunnies, and even to furry white blankets. So you can see how that stimulus generalization, things that are similar to the conditioned stimulus, now that you still get that conditioned response. This can also happen with extinction. So remember, with extinction, when you stop getting reinforced, or if the association stops for long enough between whatever the two things are that you're learning, then eventually the behavior goes back to its normal level. Well, extinction can generalize. So let's think of a operant conditioning example. Let's say that you've learned to press a button to turn on a light. So you're in a room, you press a button, the light turns on. Well, that's your positive reinforcement. So you learn in this room, when I press on this light, the light goes on. So you learn it very quickly. Now let's say you turn on the lights in other buildings. That's stimulus generalization. You realize when I go to another room and I turn it on, the light's going to go on there too. But then let's say you go back to the original room and you press the button, and it doesn't matter how many times you press it, the light stops working. So in other words, that becomes extinct. You're not going to press the light anymore. You think that that pressing that button is no longer going to give you that reinforcement of having the lights go on in the room. That's probably going to generalize to other rooms too, where you're going to stop pressing the light buttons in all of the rooms, not just the original room. Okay, so stimulus generalization also works with extinction. So it can work on with classical conditioning. It can work with operant conditioning. It can work with extinction. It works the same with reinforcement and with punishment. So let's say you're punished for talking at school, you might become less likely to talk at home because you're generalized to this other situation. Okay. Now, learning doesn't always spread to other stimuli. So it did, like in Little Albert's case, in the example of talking, but how could we make it where it would be more likely for it to spread? If you want this behavior that's learned, so maybe you have a 5-year-old and you notice that they're reading a book and they seem to be interested in reading this particular book. Maybe it's a Cat in the Hat book, or the book Cat in the Hat. Let's say you want to increase generalization. You want them to start reading other books too. What are some things you could do? Well, one thing that you could do is reinforce the reading in multiple settings. So when your daughter is reading in their bedroom and you go, yay, look at you reading that book, that's great. Now also reinforce them positively when they're reading that book in another room, or even in when they're outside or something. Provide lots of examples. So that will help. It's harder to think of the reading the book example for that. But how do we learn how to do different math problems using the same principles? You get a worksheet with tons and tons of different math problems on it. Vary the consequences of behavior. So you notice your daughter reading The Cat in the Hat. So one time you cheer, another times you instead of cheering, you say, you know what, you have been spending your time reading, so I'm going to give you extra time watching TV or something that you know that she likes, some kind of treat that you know they like. Reinforce generalization. So you had reinforced going, yay, look at you reading Cat in the Hat. When you notice her reading a different book, say, oh my goodness, you're not just reading Cat in the Hat, now you're reading the second book too. So you're reinforcing the generalization of the behavior. And that is what they use with generalization therapy. So therapy can become really difficult. Like, let's say someone's afraid of birds and you're going to use classical conditioning to get them to become less afraid of birds. So you're going to first get them comfortable with a feather in the room, and then get them comfortable with looking at a picture of a bird, and then eventually get them comfortable with an actual bird. Well, that's all well and good, but all of that's done in the therapist's office. How can you get that to generalize to the person's home, or to being outside, or being on a beach where there's seagulls and such? So generalization therapy tries to reinforce generalization of the different stimuli. Okay. All right, so that's generalization. Now let's talk about discrimination, because generalization is when things that are similar to the stimuli or the situation or end up getting generalized to other situations, other times, other people, other responses, right? But if that happened all the time, then eventually we would be making the same response to everything, because to some extent everything would generalize. So we also have this other thing that's going on that's keeping things small, discrimination. So this is the tendency for a behavior to occur in one situation, but not the others. So it's when you discriminate between when this will give me a reward and when it won't. So if we go back to the example I talked about earlier with the Advil for a headache, I might discriminate and realize that Advil is really good for a headache, but Tylenol is better for a muscle ache, or vice versa. Does that kind of make sense? So we learn to discriminate between the stimuli too. So the less similar a stimulus is to the training stimulus, the less likely the behavior is to transfer. And the cute example that Dr. Stephanie Stern has in this little picture is a child who behaves really well for an aunt or an uncle or the mother, but not to a teenage babysitter. So the child learns how to behave well for the parent. And then if an aunt or uncle are there, that generalizes to them, but it doesn't generalize. In fact, it discriminates to someone who's younger, like a teenage babysitter. Okay, if we want to train discrimination, this is how you would do it with classical conditioning. So the example that we have here is, let's say that we want, for some reason, a child to associate one stuffed animal. In this case, let's just pretend this is a leopard. I don't know what it is, but this stuffed animal, you want this child to like this stuffed animal, but not like the dog stuffed animal over here. So if you train the child to like this stuffed animal, it may generalize to this stuffed animal. Look at how similar they are. But if you want the child to be able to discriminate between the two, what you can do is, whenever you present this stuffed animal, present some kind of something positive. It could be this sticker with a smiley face on it that leads to pleasure for the child. So this is your US that's leading to unconditioned response of happiness or satisfaction or something. So you're going to pair this with this pleasant stimuli. But whenever you present this stuffed animal, you're not going to pair it with the pleasant stimulus. You're not going to present it with the US to lead to the UR. And after not too many trainings, the child will like this animal more than this animal. This animal will lead to positive feelings. This animal will not. Stuffed animal will not. Okay? So we can condition a child to associate one toy with happiness, but not the other. With operant conditioning, you can do a similar thing, like always reinforce one animal and not reinforce the other. But also what you can do is make it even better by reinforce one and punish the other. So when the child's playing with this animal, this stuffed animal, the child gets a lollipop. But when the child plays with this stuffed animal, she ends up in timeout. So you can see how very quickly the child's going to discriminate between these two stuffed animals. Okay, so that's discrimination. Now let's talk about stimulus control. So what are we talking about with stimulus control? Well, when a behavior is under the influence of a discriminant stimuli, it's said to be under stimulus control. So for example, while you're driving, you're under the influence of traffic lights. You've been trained that when the traffic light is green, you go, but if the traffic light is red, you stop. Okay, so there's lots and lots of stimulus control things. You've learned through your life so far that you act one way at a college party, a different way at a work event, and a different way at a family gathering. So we learn that the stimulus of being at a college party versus the stimulus of being at a work party versus the stimulus of being at a family gathering lead to different behaviors. So, and you can say, well, my behavior is being controlled by this situation, but it's less that the situation's controlling you and more that you have learned when certain behaviors are appropriate, right? So that's stimulus control. Now, how can we use all of this? How can generalization and discrimination help us understand behavior? Well, trying to understand this is behavior analysis. And so let's look at this problem. This is one of the things your book talks about, a mental rotation. If I ask you, are these letters backwards or not? What you're probably going to do is mentally rotate these letters. You're going to rotate them, and then you're going to let me know if they're backwards or not. How did you solve this problem? The more in line with usual positioning, the quicker people tend to respond to the question. So it appears that in our mind, we rotate it and then we decide what's going on. Can you see how that is a way of, we're under stimulus control? The stimulus is there, we're controlling it to make our decision. Okay, we rotate the images mentally until they're normal. Another example is back here. This is generalization. We haven't seen the A the way it's supposed to look. It's on its side, but we generalize it as we rotate it, and then we decide what the correct answer is. Concept formation is another place where we're using these. So we're going to use a group of things that share a similar feature. We're going to then create that. We're going to call that a concept. And when we create a concept, we're going to use we're going to use both generalization and discrimination, because we're looking, so the example that Dr. Stern has here, a butterfly. These are both butterflies. We're going to pay attention to the ways that these things are the same, that's generalization, and we're going to pay attention to the ways these butterflies are different from non-butterflies. So we're going to use generalization at the same time. So the defining features will allow us to discriminate between group members, in this case butterflies, and non-group members, non-butterflies. And of course, it's going to use generalization too. And we can train animals to understand species. And your book talks about how pigeons were given treats when they pecked pictures of humans. And in no time at all, they were pecking human pictures. And it didn't matter, like you could show all different forms. They learned how to create a concept of what a human is. Stimulus control can help us to understand smoking relapse, how hard it is to stop smoking. So we learned before that being in a situation previously associated with smoking can lead you to want to smoke again. So if you're discriminative stimulus, if you're around another person who is smoking, that's likely to prompt you to smoke again because you're watching someone smoke. Now there's two stimulus control options. You can either avoid stimuli that prompt smoking. Well, that's going to be really hard. That means you have to avoid anyone who is smoking. You're going to have to avoid places where people do smoke. You're going to have to avoid in a store seeing cigarettes. It's going to be really hard. There are a lot of stimuli that prompt smoking that were associated with that smoking habit you had. Another thing we could do is stimulus training. So similar to systematic desensitization, we can expose you to the smoking situation without letting you smoke. We're going to have you hang out with that person who's smoking, but not smoke when you're with them. And each time that you expose yourself to that and you don't smoke, especially if you'll reinforce yourself afterwards for not smoking in that situation, you are making stronger and stronger that connection to, I can be in this situation and not smoke. You can see how stimulus training is probably going to work better than avoiding stimuli that lead to smoking. What you're doing is you're training yourself to not smoke in situations that are tempting until eventually they're not even tempting. Okay. So that is chapter 11. And if you have any questions, yep, that's it. If you have any questions, please email me, maryd@cameron.edu. All right, thank you.